can we calculate beauty? Can we calculate how to design beautiful objects? Some people say yes. And yes, in the previous videos, I explained briefly what a golden ratio is, and that if the objects follow the golden ratio, they are considered beautiful. In this video, I would like to provide more detailed explanation of what the golden ratio is and calculations. So, to explain how I know that the golden ratio is 1.618. How do you get this result? Okay, so the whole idea is that, let's say I want to design a perfect face. And the length of the face, say 20 centimeters. Now, the first thing I want to decide is where to put the nose, the peak of the nose. Okay, so the peak of the nose will divide the length of the face into two parts, longer and shorter. And the whole idea is that it will be in a perfect position if the ratio of the longer part and the shorter is exactly the same as the whole face and the longer part. Confusing. Okay, let's say, let's calculate the ratios. If I decide to put my nose in 1/4 of my face. Okay, I already know it won't be a good idea, but let's see the calculations. Let's see how to calculate that it is not a good idea. If I put 20 centimeters of the face in 1/4, I put the nose. So this part is 5 centimeters and this part is 15 centimeters. So the ratio of longer and shorter part is 15/5, so 3. The ratio of the whole face, 20, of the longer part, 15, is 20 by 15, 4/3. So 1 1/3. Now 3 and 1 1/3 are different numbers. They're not the same. And the whole idea is that if they are the same, if those answers are the same, it is in the perfect position, it is the perfect division. And now this ratio we can calculate. What should be this ratio? Where should I put the nose to make it beautiful? I can calculate, but you'll have to be patient. It will be algebra, it will be quadratic equation. But how cool is it? If I know algebra, I can calculate where to put my nose to make it beautiful. Okay, so as I mentioned, longer, so B on my explanation, by shorter, so by A, has to be the same as the whole interval, so A plus B, over the longer, so B. Now, people say that this perfect ratio is phi. Okay, that's how they denote it. So phi is B over A. Now, to solve this equation, to find this perfect ratio, I will have to split this fraction into two parts. A plus B over B is A over B plus B over B. Now the magic happens. I already said that B over A is phi. Okay, so this is phi. Easy, I put it there. Now, A over B. Okay, so B over A is phi. A over B, I have to flip it. B over A is phi, so A over B is 1 over phi, the reciprocal. I have to spin it. Now, B over B is 1. So I have an equation which I will show you how to solve. Well, first of all, everyone hates fractions. I don't want this fraction. I don't want to have 1 over phi. It makes things complicated. For sure, I want to get rid of it. For sure. So I just multiply everything by phi. Oh, no, careful. Careful, always be careful. Multiplying both sides of the equation by phi might be dangerous. Because we can't just multiply by, phi represents a number. I can't multiply both sides of the equation by any number. I can't multiply by 0 because I will just destroy the whole equation. It will be just 0 equals 0. This doesn't make sense. It doesn't make sense. But I'm safe because phi is a ratio. So I have one interval, no matter what intervals you have. One interval, the length divided by the length of a different interval. Well, the answer won't be 0. It will be positive. So I can just multiply both sides by phi. And what do I get there? Phi times phi is phi squared. Okay. 1 over phi times phi, oh, you just simplify, top and bottom, you just cross out, and it's 1. And 1 times phi is phi. And this is a quadratic equation. I know how to solve quadratic equations. There is an easy formula I can use to solve it. So first of all, I have to take everything on the left-hand side of the equation. I just take it to the left-hand side. So I get phi squared minus phi minus 1 equals to 0. To solve this equation, I will have to first find out how many solutions it has. And because with the quadratic equations, it might be different. Sometimes it's 2 or 1 or 0 solutions. So first I find a discriminant, this triangle, the delta. It's b squared minus 4ac. What are a, b, and c? Easy. A is this number next to phi squared. Well, how many phi squared do I have in this equation? 1 phi squared. So phi squared. So a is 1. Now b is this number next to phi. I have minus 1 phi. So b is minus 1. And then c is this number, just a long number without phi, the constant term. So also minus 1. And I just substitute to the formula. B squared, so minus 1 squared, 1. Minus 4 times 1 times minus 1. Well, 2 minuses make a plus, so it's plus 4. Delta is 5. And the rule is that if delta is positive, you have two solutions. Equal to 0, one solution. Less than 0, no solutions. Our delta is positive. So we have two solutions, and there are just equations for those solutions. Again, a quadratic equation is an easy thing to solve, so even a calculator can solve it, a computer. But, well, it's kind of cool that I can find it out without using anything. I can just find it out by myself. You just use those two formulas. So the first one is minus b, so again, minus 1, so plus 1, minus square root of b squared minus 4ac delta, which we know is 5, over 2a, so 2 times 1, so 2. And we have the first solution. The second solution is the same, the only difference is that instead of minus, you have plus between minus b and root of delta. Now, no. One of those solutions is suspicious. Why? Because you have 1 minus root of 5. Root of 5 is 2 point something. 1 minus 2 is negative. So this solution is negative. And phi was our ratio. Well, ratio, so the division of the lengths, can't be negative. So this solution you just throw away. The second solution is fine. 1 plus root of 5 over 2. So this is the solution. This is the solution. This is this ratio. If you put it now in the calculator, you get 1.618. Exactly 1 plus root of 5 over 2, approximately 1.618. And you have the answer. If you want the object you design to follow the golden ratio, so if the interval is split into two parts, the ratio of longer and shorter is exactly the same as the whole interval and longer, then this ratio has to be 1.618 approximately, and then it is perfect. It is beautiful. And now I already found some apps which use it. You can take a picture and the app will calculate the ratios of the intervals and will tell you if you're beautiful or not. It's not very popular, I don't know, maybe it's not working, or maybe it's just telling everyone that they're ugly so no one uses it. Also, do you know that James Bond's car in GoldenEye, I think, There are two James Bond films in which he drives Aston Martin. Aston Martin, this company used the golden ratio in design. They tried to design their cars in such a way that they follow the golden ratio. Are Aston Martin's cars the most beautiful ones? I don't know. I wouldn't mind having one. Now, as I mentioned before, flowers, plants, when they grow, they use this number 1.618, which is pretty amazing. And I will show you how they do it in the next video.